Now this plays off of the concept that we were just discussing, multiplying radical terms, in which we said any two terms can be multiplied. So radical A can be multiplied times radical B to give us A times B, or radical A times B. Simplifying radicals is essentially going the opposite direction, taking a radical term and breaking it up into two separate radicals. So the first radical times the second radical gives us one radical with the radicands multiplied, or we can break it up into two radical terms being multiplied by each other. All right, so since any radical terms can be multiplied, then any radical can be broken up into a product of its factors. So let's take a look at this with actual values. Let's say we had the square root of 8, or radical 8, and we wanted to simplify it. We would break it up into a product of radical 4 times radical 2, and we choose these two factors of 8 because 4 is a perfect square. We can find the square root of 4, which should be 2, allowing us to simplify this term, radical 8, into 2 times radical 2. Now, why do we want to go through the trouble of simplifying a radical term? It's because in some examples, we'll have multiple radical terms, and as it first appears, an expression like this, radical 8 plus 3 times radical 2 are not like terms. But when we simplify radical 8 and we get 2 radical 2, now we have two like terms that can be combined further by adding their coefficients. So simplifying radicals is a method that is going to help us consolidate radical terms. Now, in the previous example that we saw a few moments ago, we had 40 radical 24. So if we wanted to simplify a radical, step 1 is to remove a factor that is a perfect square. In this case, if we're considering the factors of 24, we would have 1 times 24, which would not help us. We would have 2 times 12, but 12 is not a perfect square. Then we get 4 times 6. And we choose these factors because 4 is a perfect square. The square root of 4 is 2. So this allows us to go from 40 times radical 4 times radical 6. We evaluate radical 4, which is equal to 2. And now we have 40 times 2, which gives us 80. And that is how we wound up with 80 radical 6. Okay, so when you are simplifying radicals, again, examine the radicand. Consider the different factors that will allow you to get to the radicand, and then choose the pair of factors, one of which is a perfect square, so that you can simplify this radical, and then change your coefficient along with the new radicand. Let's have you do a few practice questions. Simplify question number 1, the square root of 48. Question number 2, the square root of 50. Question number 3, the square root of 60. And question number 4, the square root of 72. Pause the video, answer these questions, and then press play when you are ready to begin. Step 1, remove a factor that is a perfect square. In this case, that would be 16. 16 times 3 equals 48. So we wind up with radical 16 times radical 3. Step 2, simplify the radical. So the square root of 16 is equivalent to 4. So the answer to question number 1 is 4 radical 3. Question number 2, the square root of 50. Step 1, remove a factor that is a perfect square. So if we're considering the factors of 50, 2 times 25 equals 50. And we like these factors because 25 is a perfect square. The square root of 25 is 5. So the answer to question number 2 is 5 radical 2. Question number 3, the square root of 60. Step 1, remove a factor that is a perfect square. So two factors of 60 are 4 times 15. 4 is a perfect square as we know, so we use that, giving us 2 radical 15. And then lastly, question number 4. Step 1, remove a factor from 72 that is a perfect square. That would be 36. 36 times 2 equals 72. Step 2, simplify the radical. The square root of 36 is 6, giving us the answer 6 radical 2 for question number 4.